In this orthokeratology case, we're working with a patient who dropped out of soft contact lens wear due to poor comfort. And if we look at the prescription, it's just an astigmatic prescription, and the patient is still not getting real good vision post-treatment. So this is a tough case. I have to say the initial lens um, resulted in a post-wear refraction of, I think, plus 75, minus 75. So that initial lens actually did a pretty good job of sphericalizing the cornea, where there's a half diopter, got rid of that half diopter. But if we look at the patient's refraction, there's still 3/4 remaining, which must be internal. So really the only way to get rid of that part of the refraction would be to kind of induce with the rule toricity on this cornea. So removing all the corneal toricity will not completely correct this patient's refractive error. We'd actually have to induce corneal toricity in the opposite direction of the refraction in order to get rid of that cylinder. And that is not easy. It, to remove cylinder from the cornea or to correct corneal cylinder is more easily done than taking a against the rule cornea and turning it into a with the rule cornea to correct any internal astigmatism. That said, if you're really interested and the patient's really interested in trying different things, it's just time and money, and optometrists fortunately have unlimited quantities of both, and I can show you how we can create an oval optic zone to possibly induce corneal toricity. Honestly, the chance for success, I think, is very, very low. But for discussion's sake or maybe demonstration's sake, what we want to do is flatten the cornea in the, let's see, we want to flatten it in the horizontal meridian so that vertically there's a little bit more power to correct the against the rule cylinder that's there. So the initial power that we have of plus 83 is probably a little bit too much for the plano part of the prescription. We can probably drop that down, and then our target is going to be a diopter and a quarter more power in the opposite meridian. I'll show you what I mean. So in 100% mode, I'm going to drop this down until it's around 0.1, since our spherical component of the over-refraction was plus 75. And let's see if we're pretty consistent all the way around. Yeah, that's pretty close. And then in 50% mode, in the horizontal meridian, we're going to reduce the size of the OZ and the IC. We're starting with 6268, I believe. So we're going to drop this down to 5.6 and 6.2. We're in freeform mode, so we have to do the same thing over here. And then you can see how the size of the optic zone or the treatment zone changes in the different meridians. Okay, so vertically we're at our initial adjustment of 0.1. Now we want our differential to be about 1.25, so the power in the horizontal meridian is going to be about 1.3. So we'll go to the horizontal and we'll click up now. Same thing on this side. like that one's closer. Okay, so now we have point 0.1 vertically, 1.3 horizontally for an approximate differential of 1.2. You can see that the central bullseye does have an oval pattern to it. The return zone is kind of faded, especially superiorly, but that's because we're really inducing very little molding there, theoretically. So on the screen, that looks pretty good. Um, Again, in real life, the chance for success is kind of low. But if you're interested in trying and the patient's interested in trying, I think this is worth a shot. So you can do the same thing in the left eye. You want a differential of 1.25. You can decrease the overall power first. The same thing. We'll go into the horizontal meridian, reduce the OZ and IC, and add in a diopter and a quarter of additional power to see if we can turn this cornea into something that looks more like a with the rule cornea and correct some of that internal cylinder. So best of luck with this patient, and thanks for watching.